All right, ladies and gentlemen, today we're going to be looking at two-step equations. So again, let's go to Math 7, Chapter 3, 3.5, solving two-step equations. So the two-step equations, we're really just going to be combining the lessons that we did previously with the adding, subtracting, and then the multiplying and dividing. Now, there might be one or two problems thrown in there that deal with your distributive property, and then you do the adding, subtracting, and multiplying, dividing. All right, so small reminder. Let's have the variable on the left side, which we actually do here and with on your own, so I won't have to make that adjustment that I showed you previously. Now, the order that we solve them in is essentially the order that we did our previous lessons. We're going to start with our adding, subtracting. Then we're going to move to our multiplying, dividing. Now, remember, it's going to be either add or subtract, then multiply or divide. And again, we look at how the problem is structured. So it says a plus 5. So to undo an add or addition of 5, we're going to have to do subtraction. And that's what they did here. Be careful with your combining. Gives us negative 3. Negative 3x, just like the previous lesson, I'm going to go ahead and divide both sides by negative 3. It gives me my answer. You could technically check it as well by substituting it back into the original problem, and that's what they did over here. Negative 3 times 1 is negative 3. Negative 3 plus 5, yes, that does give us a 2. So we'll do those problems together. We'll focus a little bit more specific on number 3 with our distributive property there. Now, when you have fractions, we want to remind ourselves in order to add or subtract fractions, you do need the same denominator. And if you notice here, when they add 1/2 to both sides, you do have the same denominator, so it should be good there. You may be asking or wondering how they got the negative 3. Remember, a negative 7 plus 1 is a negative 6, and a negative 6 divided by 2 is a negative 3. Then we multiply both sides essentially by the reciprocal, and we're good to go. Check is over here. All right, and then we'll do a few fractional problems like that. Now, I don't know why they squeezed this in here, but technically they did. This is really, I guess this is a two-step problem, because if you notice, we're going to combine these like terms first. 3y subtract 8y is a negative 5y. Then you divide each side by negative 5, which they did not show. Shame on them. And you get your answer of negative 5. So I guess that is still technically two steps. Real life application. Ooh, roller coaster. I want to go on a roller coaster again. Some of you may be like, I want to get out of my house. All right. And maybe we'll try some of those as well. We'll come back to that. All right, let's go ahead and jump to some sample problems here. All right, two-step problems. We're going to go ahead kind of quick on this here. I can just go ahead and subtract 12 right there. 2x is equal to 4 subtract 12, negative 8. Divide by 2. Ooh, very nice. So x is equal to negative 4. If you were to check it again, you would substitute negative 4 where the x is located. All right, next one. Subtract 9, both sides. Negative 5c is equal to negative 16 and negative 9 is negative 25. Divide both sides by negative 5. It's just one step after another. Building mastery, fluency, whatever word you like to use, meaning you can do it quickly. Negative divided by negative is positive 5. Every time. All right, so on this one, technically it's a three-step problem, which is considered a multi-step problem. So again, they kind of snuck it in there. So distributive property, 3 times x is 3x. 3 times negative 4 is negative 12, is equal to 9. Now I have it as a two-step problem. So let's go ahead and add 12 to both sides. 3x is equal to 21. Divide both sides by 3. So x is equal to 7. Now, I would like to show you an alternative method here where only a few students kind of understand. So let's go ahead and redo that problem. Now, again, this is for those of you who want to think a little bit more critically. So let's say I have this here, 3 times something is equal to 9. Well, isn't 3 times 3 9? You should say, yes, Mr. Mario, that is correct. So what if I were to do this step here instead? Divide by 3. So that means 3 divided by 3 is 1, so it's kind of gone. So that means I have x subtract 4 is equal to 3. And isn't that the stuff that was inside the parentheses? And didn't we say that 3 times 3 is equal to 9? So it means inside the parentheses is x subtract 4, inside the parentheses is 3. So it means they're equal to each other. So I add 4 to both sides, so it means x is equal to 7. Oh, so like that would be a two-step problem. The way that I showed you originally, kind of a multi-step problem. All right, fractions. If it helps you again, you're going to put little ones there. So let's subtract 6. So that would be half m is equal to 4. We're going to go ahead and multiply by the reciprocal. So again, it's just quickly combining those two previous lessons. So that means m is equal to 8. Looks good. All right, let me clear out some room. Oops. On number 5, you want to put a little 1 there. That's fine. Subtract 5. Subtract 5. So I've got negative 1/3 z. I'm going to put a little line there so it doesn't look like a messy 2, is equal to 4. We're going to go ahead and multiply both sides by the reciprocal, so negative 3 over 1. Put a little 1 there if you like. So it means z is equal to, no cross canceling, positive multiplied by negative is negative. 4 times 3 is negative 12. Very nice. All right, looking at the fractions. Again, don't freak out about the fractions, just do what you can. So starting with the non-variable number here, so 2/5, I'm going to subtract 2/5 from both sides. So that gives me 4a is equal to negative 8/5. Because negative 6, negative 2 gives us negative 8, right? Now, normally I would divide both sides by 4. But if you notice, I've got a fraction here. And if I do that, it would end up looking like this. Negative 8 over 5 divided by 4. And not a lot of students can do it when it's presented that way. Some of you can. So what you can do, though, is use the reciprocal idea. So whenever you have a fraction like here, this is probably a better idea. Multiply both sides by the reciprocal. The reciprocal of 4 over 1 is 1 over 4. And this allows me to look for cross-canceling. A negative multiplied by a positive is a negative. 4 and 8 can cross-cancel. 4 becomes a 1. 8 becomes a 2. Multiply by 1s, I just get negative 2/5. Beautiful. Now again, if you were to check it, you'd substitute it in at the original location. All right, the last idea. Let me see if I can get it ready for us. The ones that require a little bit of combining like terms first. So number 7, the skill that I showed you with again here. So it's really kind of like a multi-step problem. So we've got negative 2y, and then a 4 plus a 3 is a 7 is equal to negative 9. So I'm going to go ahead and subtract 7 both sides. So negative 2y is equal to a negative 16. Divide both sides by negative 2. So a negative divided by a negative is a positive. 16 divided by 2 is 8. Very nice, very nice. All right, on this one, let's see if I can squeeze it right there. A 7x subtracted 10x. So I think this one will be a two-step problem. That gives us a negative 3x. Divide by negative 3. Positive divided by negative is a negative, negative 5. All right, very good, very good. All right, for this one here, I'm actually going to put that negative 8 on the other side. These are like terms here, 1.3m. You don't really have to box it because they're the only things there. How about that? But I could do adding the opposite. So it's 1.3 and negative 2.1, which would give me a negative 0.8 m. So you would divide both sides by negative 0.8. Negative divided by negative is a positive, and some of you might be like, well, what do I do here? If you need to, you could always structure it. Remember, 8 goes inside your little division box, house, whatever you want to call it, the 0.8 outside. Got to put a little decimal there, because again, the rule is move it once. 8 goes into 8 one time, and then you got a 0 there. So let's see. Should come out to 10. Because if I were to check it, and I were to substitute a 10 in here for each one, 1.3 times 10, negative 2.1 times 10, that would really be like a 13 subtract a 21. And that should give me a negative 8. Beautiful. All right, be awesome. Again, continue to send us any questions that you may have. Remember to check the website so that you don't fall behind. All right, be excellent or be awesome. Which one? I like awesome.